Here we have two exercises for you to try on your own using L'Hopital's rule. Part A says the limit as x goes to 0 of the quantity e to the x minus sine x minus 1 over the quantity x to the fourth plus 8x cubed plus 12x squared. A hint for part A, if you apply L'Hopital's rule and you still get 0 over 0 or infinity over infinity, apply it again, right? Sometimes you have to apply this thing 3 or 4 times to get it to work out. For part B, we have the limit as x goes to infinity of inverse tangent of x minus pi over 2 all over 1 over x. And a hint for this one is to remember what the graph of arctan looks like. It's super useful as you do limits, and this will be useful in Calc 2 as well. But it looks like this. Alright, remembering this graph of arctan of x tells you a lot, because we can see from this that the limit as x approaches infinity of arctan of x is what? Well, it's pi over 2. And similarly, the limit as x goes to negative infinity of arctan of x, this negative infinity of arctan of x, is negative pi over 2. So use that, see if you can get part B as well as part A. Just a quick review of L'Hopital's rule. You essentially check to see that your limit without any alteration equals 0 over 0 or infinity over infinity. If that's the case, you take the derivative of the top, derivative of the bottom, and try again. Note that it's not the quotient rule. Okay, so pause the video, try these out, see what you get, and then we'll work them together. Okay, well, when we plug in 0 for x in part A, we do get 0 over 0. So check that is the correct kind of indeterminate form. So we hit this with L'Hopital's rule, which means we say equals by L'Hopital's rule. And then it's still the limit, so you want to keep evaluating this limit. Limit as x goes to 0. The derivative of the top is e to the x minus cos x. Divided by, and then the derivative of the bottom, we're just hitting it with the power rule. So 4x cubed plus 24x squared plus 24x. Evaluating this limit, well, that gives us, again, 0 over 0. Okay, well, I'm going to take that as good news. Check, because we're still in the right form to use L'Hopital's rule. So let's evaluate it again. Or let's use L'Hopital's on it again. So equals again by L'Hopital's rule. Still evaluating the limit, so I'm going to write the limit out here. Limit as x goes to 0. Now we're back to e to the x. This becomes plus sine x over, well, let's see, 12x squared plus 48x, let's see, plus 24. And now when we plug in 0 for x, we get 1 over 24. And that's our answer. Okay, so don't be afraid to apply L'Hopital's rule a couple times if needed. Let's look at B. If we just plug in infinity for x, we get pi over 2 minus pi over 2 all over 1 over infinity, essentially, although that's a little bit sloppy. But essentially that gives us 0 over 0. Check. That's the correct indeterminate form. So it's indeterminate. That's the bad news. The good news is we're in the form we want for L'Hopital's rule. So we hit the numerator and the denominator with the derivative. Be careful not to use the quotient rule. That will send you down the wrong path, and it's a lot more work. So this equals by L'Hopital's rule, the limit still, as x goes to infinity. You want to keep writing the limit out until you've actually evaluated it. Well, the derivative of arctan is 1 over 1 plus x squared. That pi over 2 drops out. The derivative of 1 over x is negative 1 over x squared. You can think of 1 over x as x to the negative 1 and get the derivative that way. Please don't use the quotient rule on 1 over x. That's a lot of extra work. Instead, write it as x to the negative 1 and use the power rule. Though you can use the quotient rule. It's just not the best use of your time. Okay, well now we're getting somewhere. This looks like we have the limit as x goes to infinity of, how about negative x squared over 1 plus x squared. That's just multiplying by the reciprocal. Now there are multiple ways of evaluating this limit from here. You can use this technique you already know from this class. There's even pre-calculus techniques to evaluate it. I'm going to keep going with L'Hopital's rule. right? We get infinity over infinity, but you certainly don't have to. Once you see a way off and you just want to evaluate it, maybe you can see already that this is -1 using a previous technique. But I'm going to keep going with L'Hopital's rule. Okay, so why not equals limit as x goes to infinity of, how about -2x over 2x. The x's cancel, leaving us with -2 over 2, which is -1. So L'Hopital's rule can really deal with some incredible limits. The only thing is you have to make sure that it meets those conditions before you use it.